All right, we're hoping to understand what's going on when we graph trigonometric functions, starting with sine of theta. So first of all, let's think about what's going on when we graph sine theta. To do that, let's look at our unit circle. So on our unit circle, we have these angles. That's what theta represents, that are coming out from the center of the circle. And when we pick our angle, it's going to direct us to a certain y value on the circle, and that is sine of that angle. So a bigger angle is going to give us a bigger y value. A smaller angle is going to give us a smaller y value. So what we can do, we can represent these y values as vertical lines, just with a length of that y value. So let's say we just pick a random angle. It's going to direct us to our circle. Well, we just pick a bunch of random angles, and then we'll just drop a vertical line down from where it takes us on the unit circle. So here we go. They're not going to be perfect, but that's okay. We'll get the idea still. All the way until we get to pi over 2, where y is 1. So then what we're going to do, I have to get this unit circle out of here so I can drag these lines over. So we have to drag them over, but it's kind of confusing because the unit circle goes counterclockwise, so we move like this, right? But the x-axis moves this way. So when we put these lines on the x-axis, we have to do it in reverse order. So here's the first one. We'll just try to evenly space them. All right. This is lots of fun. Alright, now I'm going to skip ahead to have all of them on there, so just one sec. Okay, so now I've moved them all. This is our first quadrant of our unit circle. And then we know that at when the angle is 0, we're at y equals 0. So we can just put a point at 0, 0. Alright? And then we can draw our line. There we go. That represents the first quadrant of our unit circle, the sine graph. So again, notice if we go from 0 to pi over 2, our angle is progressively getting bigger, and as our angle progressively gets bigger, our y value progressively gets bigger. But then it hits 90 degrees. And now we're going to start going down again because our reference angle, 120 degrees is greater than 90 degrees, but our reference angle is going to start getting smaller again. Right? Remember, our reference angle is how far away we are from the x-axis. So as we move along again, now we're going to start going down. So we don't have to do the line thing again. I can just symmetrically draw this. Okay, so we go down to pi. So that's what happens when we go from, on our unit circle, pi over 2 to pi. Our angles are getting smaller, 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 smaller. So now our y values are getting smaller, 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 smaller until they hit 180 degrees where y is 0 again. And now we're going to start hitting the negative values down here in the TC quadrants where only tangent and cosine are positive. Sine is negative. And it's going to be a similar thing though. We are going to go down, 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 down until we hit 3 pi over 2. And then after 3 pi over 2, it's going to start going up, 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 up again. And then there is one period of the sine curve. A couple things. I realize this is confusing. That's not 0. I'm just saying that this is x equals 0. Right? X equals 0. So then down here is negative 1, and then up here is 1. So then that's just one period. We know that we can continually go around and around and around and around our circle and get more and more periods of our function. So let me just add a couple pictures in here. Pause. Okay, so here we have a sine function that extends forever. So there's one period, right? 1 period, 2 periods, and then we keep going and going and going. And then this is zoomed all the way out to, so you can see the x equals 100, x equals negative 100. And again, it's just bouncing up and down, bouncing up and down over and over and over again as we continually travel around and around and around our unit circle. So that is the graph of sine. That's where it comes from. That's where it represents. That's what it represents. And that's it. What a great conclusion by me.